My name is Engineer. My name is Engineer Chima. As always, I've been the lead discussant in the last 2 Saturdays, and then I'll just run us through. I hope everyone can hear me. Just I need a feedback to know that everyone can hear me.
Yes, we can hear you, sir.
Okay, awesome, great. Yeah, before Engineer Uche comes in with the software, I also want to make us understand that we can as well develop some of these calculations on Excel. Excel is a very powerful tool that you can also use as designers, as engineers, as installers. We can also do some of these simple basic calculations. I mean, the calculations that we did in the last Saturday, you can actually program, not exactly programming, but you can as well, put this in an Excel such that you don't need to be doing those calculations all the time. When you meet a client, just take their basic details, and then you begin to see something that might want somehow represent the kind of installation that you might want to do for them. Then you cannot take it off from there to ask some other detailed question, for example, regarding the economic variables like a budget, a capital layout, and some other thing that you might want to. But essentially, what I'm going to present to you is just more like the first analysis that you can do when you're discussing with a client, because essentially you just want to know what the need of the client is. When we're talking about solar installation, you want to understand what the client wants to power. For how long does the client want to power those load? It must not be accurate, but a good estimate will be very helpful in running your design and sizing. So here's an Excel tool. I developed this Excel tool, and I use it to have a sense of what a client is requesting for. And I can also discuss this with my client and show the client how some of his or her decisions affect the sizing of the system. Okay, so I'm just going to run us through this Excel. I have some basic instruction here in case I'm sharing this with someone or the client, just basic to that. First, the final cost of your solar system will depend on the power requirement of the equipment you choose to power and their duration of use. Then power critical and absolutely necessary appliances with your solar system. So you don't need to power things that are not really necessary with your solar system because of budget. So you can always keep the budget, economical. So if budget permits, reduce the power demand of your appliances by switching to more energy efficient ones. So first of all, before you install your solar system, remember when I discussed about the concept of sustainable energy development, and I said that the first thing that needs to be done is energy efficiency. Identify the losses, reduce the losses, improve your energy efficiencies of your appliances. So might want to change their conventional air conditioning system to inverter air conditioning system. I've seen a client, before the installation, he removed all his air conditioning system and bought an inverter air conditioning system just to lower the capital outlay for installing that solar system, and also to enable the battery to last over a longer period of time. So these are very, very necessary steps, to educate your clients. Solar system is not just about you going to, putting this on the roof of your client and walking away. That education needs to happen so that they can be able to use it in the right way. Otherwise, they will keep coming back to you. They will keep calling you for issues, whereas just simple education would have solved some of those issues. So number 4 rule here is that reduce the duration of using the appliances on your solar system by turning them off as soon as the task is completed. So if absolutely necessary, use high power demand appliances. If absolutely necessary, use high power demand appliances like washing machine, water pumping, ironing, etc. during the day when the sun is fully out to reduce battery storage requirement. Now, with this knowledge in mind, let's assume that we approach a client and we want to ask the client, okay, now this Excel sheet here is where we'll have to input the appliances of the client. Okay, so here you have a list of their equipment. Here you have their wattage, the power they draw from the inverter, the wattages. Here you have the quantity. Okay, here this one is calculated automatically. This total load is calculated automatically based on these 2 inputs. Then another thing you need to know, what time does the client use those appliances? So you have from 1, that is 1 a.m. in the middle of the night, to 12 noon, then 1 p.m. to 12 midnight. So you have 24 hours. So what time does the client need to use that load? So if, for example, the client is using that load by night, based on my own design of this Excel tool, I'll just put X, okay? For all the time that the client needs to use, I'll just put X in the box. And as I'm putting X, this calculation is happening automatically. Notice that the duration of use per day is changing. The energy consumption is also changing because I've already done this calculation in the Excel, right? So all I need to do is just put X in the boxes where the client needs to use this equipment. And the duration of use per day will calculate itself automatically. When you have all the list of the equipment, the wattages, the quantity, and the time of use, every other thing is automated. So at the end of the day, you will now see the total duration. This is the total duration of use per day. Okay. So this is the energy consumption per day. So this client with this equipment is going to consume 26 kilowatt hours per day, using it at this time that the client has specified here. Okay. So okay. So this is the total kilowatt load that the client is powering. Based on these ratings that we have here, the total load is 1.72 kilowatts. So for example, if I change this inverter AC now, if I change it to 2 units, it has 2 quantity. Notice that this total load will change. The energy consumption will also change. Okay, so let me go back. Let me leave it back to one unit of air conditioning system. So once I'm done with this, I will come down here and select the kind of battery I want to use. Do I want to use lead acid battery, or do I want to use lithium ion battery? So I just have these 2 options. I don't have option for any other kind of battery. I just have these 2 options, right? So if I select lithium ion battery, then I'll also select the voltage of my system. Do I want 12 volts? Do I want 24 volts? Do I want 48 volts? If I select the voltage, right, I'm done with this is a very simple, basic Excel tool for designing your system. So if I'm done with this, I will now have to come to the system report. So if I come to this system report, see what I'm going to see. Now, all of this happens automatically. I don't need to do anything here. I only need to collect the equipment, collect their wattage, collect their time of use, select the kind of battery I want, and select the system voltage. You will see this kind of report. So this is your load profile. This is the load profile of the client that we have now. Okay. So his peak is about 1.7, which is somewhere here. This is his peak. So this is his load profile over 24 hours. So I can see how he consumes energy over 24 hours. And this is a breakdown. This is a graph. This is a breakdown of his energy consumption in kilowatt hour. Now, you notice that the air conditioning system of this client consumes 65% of his energy. The air conditioning system. So with this, I can tell the client, okay, is it possible for you to reduce the hours of usage of your air conditioning system? So let us go and reduce the hours of usage of the air conditioning system. So this is air conditioning system. He uses it for 14 hours. So this is the total hours he uses air conditioning. Let us reduce it to 10 hours. So I remove this X here. 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 So it's now 10 hours. Let us go back and see what percent. Now you see that it has changed. It used to be 60 something. Now it is 57%. It has reduced. So this is the breakdown of the client's energy consumption by fridge. The fridge consumes 23%. The light bulb consumes 5%. So this is just a breakdown of energy consumption. This is the breakdown in table. I mean, you're having them in table. Okay, this is a chart. This is a table breakdown. And we will come down here. We will now see the system design. So this is the inverter capacity that will service that client. So I can use 3 kilowatt inverter for that client. It's automated already. Solar capacity is 8.27 kilowatt peak. Remember, I choose lithium ion battery. Now, if I go back and choose lead acid, let me go back and choose lead acid. So you see how this thing changes. If I choose lead acid, let's see. You can see that lead acid has already appeared here. And all of this system will also change based on the kind of battery technology I choose. So let us go back and leave it at lithium ion. So lithium ion battery depth of discharge is 90%. That is an assumption for lithium ion, okay, 90%. Cycle efficiency of the battery is 95%. Now, cycle efficiency means that when you charge a battery and discharge it, you don't get 100% of the energy you put into that battery. There are losses. So that's the cycle efficiency, and it's at 95%. For lead acid, it is low. I think it's 90%. So battery storage capacity without daytime load. Now, I try to do something here. Okay, this battery storage capacity with daytime load. What is daytime load? Means that during the day, the client is using some of the equipment. Okay, so you don't need to store energy that those equipment needs to operate. You only need to store the energy that the client needs maybe at night or during the non-sunny days. Okay, so I have two models here. One is battery storage with daytime load and battery storage without daytime load. If you have some of your equipment that are running during the day, it will reduce the amount of battery storage you need because you don't necessarily need to store all of that energy. So if you're running those equipment from 8 to 5, you don't need to store the energy. So you're using a battery storage system of 15.15 kilowatt hour. But if you're not, if during the day you're not in the house, so you need to store all that energy, your battery storage system will now increase to 24.8 kilowatt hour. Okay. Now this is our nominal system voltage. We selected 24 volts. And this is total capacity of our charge controller, 344 amps. Now, these are just estimates. These are cost estimates. Please, these changes, they are not, of course, you know, these are dollar dependent. They have dollar basis, right? So they always change, right? But I just have this as a cost estimate. Now, these are my assumptions. I also have an assumption table. So you can come here and change these assumptions. So this is the cost of solar PV. My assumption is that cost of solar PV per kilowatt is 200,000. Charge controller. So these are where you can change. These are technical assumptions you can change. Inverter power factor. Remember, when we calculated the inverter, the size of inverter, we had a power factor for the inverter. So my assumption is that inverter power factor is 80%. Load factor is 70%. If you want, you can change this assumption. So if I change this inverter load factor to 50%, I'll go back to my design. You will see that my size of inverter has now increased to 4.3 kilowatt. It used to be about 2 point something. But because I have now changed my my assumption to 50%, this has now increased to 4 point something kilowatt kVA, right? So you can change some of these assumptions here. So this lithium ion battery depth of discharge, 90%. For lead acid depth of discharge is 50%. Lithium ion cycle efficiency, I use 95%. For lead acid, I use 85%. Okay, solar peak sun hour, I use 4%. So you can change this to 5 hours, depending on the location where you're doing your solar. You can change this to 5 hours, and your design will change automatically, right? So what next? Solar performance ratio. So I use 75% as an assumption, okay? And then this is hours of daytime load is 9 hours. Remember, this assume that the person uses appliances from 8 to 5. Between the 8 to 5 is about 9 hours, right? So some of the load, some of the energy that should have been saved in a battery to power those load will not be saved because the energy will go to the load directly. So this is just an assumption. So these are basic things. If you understand the calculations, and that's why I took my time last week to explain the calculations, the formula. So all of those formula are what I used to do, what I used to create this my Excel model. It's just as simple as it is. Okay, so these are basic things you can do on your own without depending on the software. So I think I will stop here and allow Engineer Uche to come up now and then walk us through the PVsyst. Engineer Uche, over to you. I don't know. Is there any question? Is there any question? Okay.
Yes. Engineer Chima.
Yes, sir.
It's okay. Comparing the lifespan of this battery, lithium battery and lead acid battery, which one lasts longer?
Okay. Thank you for the question. The way we usually look at the lifespan of battery, we look at them as the number of cycles. All right, number of cycles. So lithium ion batteries. Remember when we are talking about standard test condition for solar systems, right? We talked about.
Who is speaking? I'll tell you everything.
Okay. Hello, Engineer Uche.
Yeah, Engineer. I have issue with one of. I'll call you back.
Okay, sorry. Your voice is
Yeah.
interfering with the class, so I want to assume you're talking to someone else. Okay, so we look at the number. When you look at the technical data sheet of this battery, you're going to see the number of cycles that the battery will last. For typical lithium-ion batteries, it's usually about 6,000 number of cycles. So what that means that the battery will charge fully and discharge fully for 6,000 number of times, and then the battery will be considered, the battery will consider to have been degraded. Not degraded to 0%, but it will have been degraded to maybe about 80% or 70%. Okay. So that's the way we look at it. Therefore, lead acid battery, maybe it's about 1,500 number of cycles. So some of these batteries, you have to look at their technical data sheet and you see that number of cycles. So the thing is that we don't usually say, okay, the battery is going to last 5 years. It depends on the number of times you charge and discharge that battery on daily basis. So if you're using a battery and you fully charge it and you discharge it 2 times in a day, then you're depleting that number of cycles. So that battery will complete its number of cycles within a short period. Now, there's a caveat to this. That number of cycles you see in your data sheet, please pay attention to the temperature. To achieve those number of cycles, those batteries must be maintained at a certain temperature, which is usually 25 degrees centigrade. And that's why for a large storage, where you have large battery storage banks, it is recommended you have an air conditioning system to maintain the temperature of those batteries. Because if the temperature is higher, those batteries are going to degrade faster. So those are the things that we should take into account when we are, installing this system. I don't know if that clearly answers your question.
Yes, it does. So from my understanding, from your explanation, it means lithium-ion battery have a higher cycle efficiency compared to the lead acid batteries. Is that correct?
Correct. Now, cycle efficiency, you need to understand what I mean by cycle efficiency. Let me ask, please. Let me trade back to you. What's your understanding of the cycle efficiency?
For me, cycle efficiency is more or less like the ability of the battery to still continue to perform after discharge and charging cycles.
I'm not very sure about what you just said, but simply put, when you put 100 units of energy in a battery, let me say 100 kilowatt hour, example, in a battery, and you are now telling the battery to give you back 100 kilowatt hour, the battery cannot give you back 100 kilowatt hour. Now, the reason is, in the process of putting that energy into the battery and in the process of collecting it back, there are losses. Okay, so those losses is what we now refer to as the cycle efficiency. So the battery cannot perform at 100% efficiency. So for lithium-ion batteries, those losses are minimal compared to lead acid battery.
Okay.
So that is cycle efficiency. Okay, but the cycle itself is the number of times you charge that battery and discharge it. If you charge the battery fully and discharge it fully, that is one cycle. Okay. Then the efficiency of the cycle is maybe 95% for maybe lithium-ion battery. Therefore, lead acid battery is usually less, maybe 85%.
Okay, thank you.
Any other question?
I think the Excel sheet is well self-explanatory.
Okay. 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 Thank you very much. Engineer Uche, are you there?
Okay. I'm there. I'm here already.
Okay. Okay. Let me stop sharing my screen and then hand over to you. Okay. So over to you now.
Okay. So I suppose that thank you, Jantima, for that. Excel is part of the computer application. I said at the beginning that Excel is such a powerful tool that will suffice for most calculation sheet and most design. Let me just emphasize on the last question someone asked. The modern trend now is lithium iron phosphates, and that is just it. Actually, the research in battery technology now is at the peak because of large storage. And Tesla is taking a lead on this, as well as other research that's going on. But so far, from what I've seen, and what I can attest to, lead-acid battery is gradually being phased out. People are moving towards lithium-ion phosphate, or lithium-ion, which is the one we use on our cell phones. And the issue is just the issue of cost. And I believe that we are still using lead-acid because of also cost. The lithium is still very expensive, and purchasing power here in Nigeria is still very poor. That's why you see a lot of people. And also, just like Chima emphasized, education is important. Many people are not really into this solar thing, right? But we are coming up. All right, so let's move. So if you have installed the software, here we are. We'll try and simulate the exercises that we have done, even including this one we just finished now. Let's see where we can introduce you to the software. So what I'm going to be doing in the next 1 hour, basically, is to introduce you to one of the software tools you can use to aid your design. So this is PVsyst. It's an Austrian software. I think I have a presentation on that, which let me quickly go through it, just to do it in 10 minutes. Yeah, so that's what it is. So this is what the software is. You can see when I prepared this slide, they still have 7.0. So today we're already on 7.4. So that's an advance. So it's from Switzerland. And this is what you might want to know. The description, you look at the tools, the interfaces. Then we have what we call preliminary design. Ideally, you do a preliminary design. After that, you now do your final or project design. Yes. So the design will be in two steps. You first of all do a preliminary design. Then you now go back and then optimize the design to come up with your final project. I think that's what we engineers do. For every design we do as engineers, there's always need for you to do a preliminary design. Then you now perfect that design and get to your project design. Then you can use the PVsyst to design 3 systems. You can use it to design the standalone system, or the one we usually call off-grid system. You can use it to do the grid connected system. And then you can also use it to do pump sizing, okay, for DC pump, DC solar pumps. So that's all about the software. Just like I said, it deals with grid connected, standalone, or off-grid. Then it also deals with pumping. So these are the 4 basic components of it. You can do preliminary design, you can do project design, then you can access databases, and then you can look at some other utilities. So this is the general interface of the software. So once you are on this page, you either go to the grid connected, or you go to the standalone, which makes use of battery, or you go and do for solar pumping. So for the preliminary design, you can do the 3 estimate. This is just for a rough estimation of what the system cost is. A rough estimate. It's not otherwise the system does everything for you. You just key in your values you've gotten, and it brings out some key performance indicators for you. Then the next thing is you can also do the final project design and simulation. But in this case, you consider the hourly simulation, just like in Yajima emphasized, load shading. When I'm using this load, daytime and off-peak use, it has a way of influencing the capacity and the cost of your system. Then we can also access the databases. Okay, you can be asking, what is the sunshine level here? What is the P-song hour here? What is the wind effect? It's a lot of questions. With this software, you don't need to ask those questions, because the software will pick those variables and then automatically use them for your design. Then the last one for the databases is that the software has a collection of the major manufacturers and generators and regulators and inverters and everything. Last week, one of us was just asking which one is best, which one is this. With this software, you definitely identify any of the major manufacturers or original equipment manufacturers, and then it will automatically incorporate their proprietary values and the unique parameters that they have. So if you, for instance, you take Jinko Solar, or you take JA Solar, or you take Tesla, it will automatically import all the components associated with that manufacturer. Okay. Of course, we also have the tools. These tools have to do with you generating tables, graphics, financial inventories, and what have you. Some of these things will help to establish your boundary, your limits, your boundary conditions, right? So that when this boundary condition changes, you will exactly just go to the software and upgrade or update them anyway. Then you can also attach your measure data in ACII format. That's a little bit advanced. So let's focus on the major one. So here's the interface. So just like Chima said, Chima, I've already gone through all this. So we've done this. Just part of what I did was to recap them. So let's quickly go to the software. So this is the software interface. Can we open the software? If you are here, you say yes. If you are here, let me have yes from you.
Please. Yes.
Okay,
so I'm on transit.
Sorry, the video will be sent. Okay, so this is the interface of the software. Most of what you have here is also here. Like for instance, if you go to preliminary, it will still give you these three options. If you go to the project, it will still give you these three options. So let's start. So we're going to simulate. Okay, so let's go to standalone. Click on standalone. Standalone. So for standalone, from what we had last week, this is our load, right? These are equipment you have in the house. So just take note of this. You can write it down. But suffice is, no, this is the wrong one. I will delete this one. Sorry. Good. So energy requirements about 3,400. The power demand is about 410. So what we do? Here we go now. So I come here, I click on standalone. Now, this is the interface, the homepage of the software. Now, here, you move the software from down to up. So now that you've started, you first of all have to work on the first row. So the first row would be to say new. You click on new, then you give it a name, right? So let's go to new. I click on new. This is it. So I come here. I can give it a name. I don't know which name to give it. I'll give it my home system. My home system. Most times, after giving it my home system, then next is. Are you talking to me? Okay, let's go. Okay. So what this software does is that this place is your interactive window. Whatever is giving you here, it will be giving you instruction of what needs to be done. When it gives you a orange instruction, it is a gentle reminder of what needs to be done. Once it gives you the red, it's like a danger, it's like a red flag, it's like you're doing the wrong thing. And when it gives you the green, then it means you are good to go. It means you are doing the right thing. So take note. So it's telling me now to choose the geographical site. So it knows that I'm supposed to choose it to authenticate the location of home system. So it is not giving me a red because it knows that's the next thing to do. So if you look at this, after clicking here, the third one is visible. So I'll go to this plus and click on the plus sign to choose the geographic site. So this is the world.
So we do not see where you plus sign you.
Okay. I close it here. New site. There it says site file. I'll go to the extreme end and click new site because my home system is going to be on a new site. So I'm going to click plus. Plus in software means add. So I'll click the plus sign, which is to add a new site. So it will take me to the global map. On that global map, I can go and click somewhere. This is Sudan or wherever. But the best thing to do is to say, come here and I'll search it. I'll just type Abuja. Let's say I'm doing the design in Abuja. But to further help him, I'll put Abuja space Nigeria. At least if he doesn't understand Abuja, if there are two Abujas in the world, it will give me the one in Abuja. So by default, the location is at Switzerland. So I need to write Abuja, Nigeria. And then I'll click search. It will search for Abuja. Is that not my Abuja? Yes, it is. Am I okay with it? You can even search, I can search Port Harcourt. Watch me. I can come here, I say Port Harcourt, Nigeria. I'll say search. It will give me Port Harcourt. Yeah, Enugu on NMB. So this is Port Harcourt. So you can choose any location. So if it chooses me, the location, it will tell me where it is, Nigeria, Port Harcourt, the longitude, the latitude, and what have you. So it doesn't matter whether you're choosing Port Harcourt or Abuja, we're just trying to do a design, right? So, but remember, my peak sun hour, so it's good we use the same location. So let me go back to Abuja because of peak sun hour.
Sir, you mean every one of us will use Abuja too?
Let's use Abuja so that we get two different results. But it's all the same. So I'll click accepted, accept selected points. But before I click selected point, I would like to see the parameters of this Abuja. So I can click on this next tab. Remember, we are learning the software. So I won't just follow it sequentially. I will also be showing you how to play around with it. The idea is for you to have a mastery of it and have that confidence to use it. At least you can comfortably say, yes, we'll be taught PVsyst as a renewable energy expert. If somebody asks you what software can you use, you can say, yes, I can use PVsyst with confidence. So if you look at it, if anybody is conversant with meteor data, okay, I'm here to select it anyway. So I will just click on this tab. If you click on this tab, it will give you the different parameters.
Sorry, sir. When I type Abuja, Nigeria in my own, it says locality Abuja not found.
Check the Abuja very well. I think you need to have it. Try Port Harcourt.
Huh?
It should.
I thought Lagos work. But when I type Abuja, it says locality Abuja, Nigeria not found.
Oh, it's a bug. Don't worry yourself. It's a bug. Just ignore it. Don't be surprised if you shut down and on your system again. It will come up. So just don't worry about it. Or type local jobs. Find somewhere close. It's a bug problem. Okay. So you can see it has given me Abuja. So I'll say accept. Let me first of all accept it. So I'll click accept selected point. Then it will now import the parameters. So you could see it's giving me a red message here. And that red message says, please import the monthly meteo data. And there are options. You can import it from NASA, PVsyst. There are many companies that are out there. This software is really cool. They keep updating it and they keep incorporating everybody. So we can use the metronome, but I would like to use NASA. NASA is American Space Agency. So I'll come here. I'll click on NASA. Right? When I click on NASA, I'll click import because it's telling me to please import. Okay, so I'll say import. I'll say okay. I'll say okay again. So you can see it has imported the global parameters, right? Which I can also come here and change their unit. I can change it to watts. This is it. So you could see if I change it to watts per meter square, it will tell me irradiations from based on the temperature. Remember, temperature has an important effect on it. So this is the radiation per meter square. And that is it. This is intensity of the power can be generated there. So if I go to global coordinates, it is there. It's just there, right? And everything. So let me not go too far.
This thing you are doing.
It's on these tabs. After interactive map, right? I say I select the data, and then I click on import. The number one is for me to say, this is Abuja. I have seen it. It's correct. This is the map of Abuja. This is Gwarimpa. This is Gwagwalada and everything. So I'm okay. So I'll click accept. And that's what I did. I clicked accept, right? And I will now click import, right? So I click import, and it had to import the data for me. I will now say, okay. If I'm not comfortable, I'll go to new site, but I'm okay. I'm okay with the data. I've gone through the coordinates, through the tabs, these tabs here. So I'll click OK. And then click save. It has converted it to a file name. So I can save it as my own unique variables. So it has named it Abuja NASA 1983. I'm okay with it. If you look here, there are ones I've created before. Your own will be blank here. But this is Katangbe Abuja. I created this one before. So this is the new one is saving now. I will say save. It says it has now saved my database. I will say okay. I will say yes. Yes. Good. I'll say yes. So now I am back to my interface.
Please, before, can you give those of us that are having issue like 1 minute for us to get catch up with you? Because my own is giving me another thing, and I have to cancel and redo it.
Okay, can you just use Port Harcourt? I know why. Don't worry. Use Port
Sorry,
Harcourt.
sorry. Do you know why you would? Even if Abuja did not display in your map, go to that configuration. I see experience same thing, so I have to follow his procedure. Just be clicking all those configurations. This same data will come out, even if you didn't see Abuja in your.
These things are called bug. You see, that's why sometimes when you're on your Samsung phone, Samsung will update it after 1 week, 2 weeks. And generally in computer, sometimes you just shut down and on and your phone, whatever it is. Merely you told me, I thought it's a bug. Okay, but to speed up, just use Port Harcourt. The idea is not for you to be perfection. You just need to have an idea. Now, look at what is happening now, gentlemen and ladies. After selecting it, the system has given me another orange feedback. It said, selected meteo file, Abuja NASA, which it has created. It is not yet saved. So it's asking me to save. And before now, the save icon was not on. So now the save icon has become on. So I'll go here and click save, right? So it will save it, this project, with a file name, and I'll say save. Good. So it has saved, but it now gave me another pop-up. It said, please choose the plain orientation with an exclamation mark. It means that is a danger. It means I need to do something about it. So I'll quickly go to orientation here and click on it, look at orientation. Now, what you're going to see here is that everything that is in red color was turned to green color or orange color. Orange color will mean that your system is not well optimized, while a green color, we said here we are good to go. So you can see the two systems, orientation and user needs, are all in red. It means I got to do something about it. It means variables are missing. So I'll first of all click on orientation. It will come up with this window. So under the plain fields, that I talked about it, I'll put 15. Azimuth, I'll leave it at 0 or 5 degrees. I mean, I'm just facing the equator, right? So let's leave it at 0. Then I will come here and say yearly. You know, there's summer, there's winter, but for we don't have summer, we don't have winter. What we have is yearly. I'll put yearly here. Under fixed type, you leave it at fixed tilted plane, just like a rooftop installation. It is fixed, it is tilted, and it's on a plane. There are many other options there, like seasonal tilt adjustment, there's tracking. All those ones are very expensive to install, of course, but just leave it at fixed thing with the assumption that it's a rooftop installation that's permanently there. If you are there, you have set here as yearly. If you have set here as yearly, and you have set the azimuth to be 15, then you have to click OK.
Sorry, sir, I want to ask a question before we continue. That plain tilt, it must always be 15% or it can change?
No, it can change. Remember, it can be up to 30. We don't remember last time we talked about self-cleaning, right? I mean, you can't lay your solar panel flat. So 5 degrees, 15 for 15 degrees ideal.
Okay, let me just let me I know at the point in our first class, I know I talked about tilt angle, and I explained that the tilt angle should be the latitude of your installation site. Okay, your tilt angle should correspond to the latitude, and I told you that in Nigeria, the latitude is about from 4 to 15 or so. I mean, if you're moving from the south to the north, down the south is about 4 degrees. If you're moving to the north, it now increases to about 15 or so degrees. So that should be that should be your tilt angle, right? Because Nigeria is also closer to the equator. You might need to go back to our first class and then look at that again. So continue, Genoche.
Okay, all right, thank you, Yachima. So are we here? So if we're here now,
I can no longer hear you. Is something wrong?
Yeah, sorry, sir. So, yeah, thank you. So, should I go back? Click on user need, you'll be here.
Okay.
User need. So I will go back here. I'll try to impute what I have on this table.
Please help us adjust your screen sharing. Is too bold and we are not seeing majority of the thing on the screen.
Is it okay now?
No, sir.
I think it's your screen.
Is
okay.
anyone yeah, is it, I wanted to say because it's fine from my end.
It's fine from my end.
Yes.
It's fine here too. I think it's our system.
So yeah, I think it's from her system.
Yes.
Okay, good one. So this is the consumption. So TV, if I remember, we have one TV, right? And the wattage is about 50, right? 50 watts. We have lights. How many lights we have there? It's about 8. What's the power again? Light bulbs, each one is 15 watts, and we have 8 of them. So the TV is 2. Wattage is 15 watts. Then under domestic appliance, I'll double click it. I think we have something like a fan there. Then we have one fridge. And the consumption is about, is it 1.8? Yeah, 1.8, I think. But the one in Excel, the one team I use in Excel, use 4 point something. Remember that. What other equipment do we have? So I think that's all we have. So the other ones will be 0. Okay, the fan is 40 watts, right?
I think the fridge is 150.
Yeah, but there is one, times 12 hours. That's 1.8. You know, this is watts per day, but the other one is kilo. So I convert it to kilo. Yeah, 150 times 12. The power is 150. Then we are expected to work for 12 hours every day.
No, but I think we have not chosen the daily hours yet. I'm looking at the other ones you did before. On your light bulbs, we have 15 watts.
Mm-hmm.
And then when we put the daily use, I think that is when we'll get, but now you're putting the hour of daily use on the fridge.
That's how fridge is calibrated, sir. Now, let me tell you this, sir. In fact, yesterday I tried to enlighten people about it. You know, your fridge is something that works. In fact, if you go to buy fridge now, they'll tell you about what it will consume in a year. The newest fridge now are consuming between 300 watts, about 300 kilowatts per year. The old ones are consuming about 500. So the next time you go to buy a new fridge, you look at it, the energy efficiency ones, some are down to 250 now. So you know the fridge is something that goes on every day, almost 24 hours. That's why here they even put 24 hours here, right? So you can adjust the other one that is 12 to 24 hours. So what is the consumption per day? I think 1.8 is very conservative and is what it is.
Yeah.
By the time you multiply it by 360, you'll be getting something close to 400, 500. I don't know if you have any other opinion, but I know that's what it is.
Yeah, I got it.
Yeah, good. So you could see that there is a red mark for me on the lamp, TV, and fan, because the system is interested in knowing the hourly usage. So it gives me a red sign telling me I need to specify a hourly usage, which is very key. If you look at my sign here, it's also giving, say appliance number 1, please define the hourly distribution. And it gave me clue. It's on the second page. So come here, on the second page here, look at it, this second tab. I'm going to click on it. I'm going to click on this second tab. I'll click on it. So you can see the fridge. It has taken the fridge 24 hours. So I'll go to fan. I don't know how many hours you're using the fan. 1 hour, I think it's 1 hour. So here, that 1 hour is poor, but let's leave it. That's what we're designing with, but I know it's very poor. I don't think. but this is just for learning purpose. So you can click in this thing. Each of these things represents 30 minutes. So this is 1 hour. This is 2 hours. This is 3 hours, right? So that is it. Then for the television usage comes in from, let's say, from 16 hours. Now this is what I'll do. If I click here, I'll hold my mouse and I'll drag. I'll drag across. So this is it. I've chosen 12 hours. Doesn't mean forget about it. I'm just trying to learn. Then for the light bulbs are usually on for 8 hours. I can still do 24 hours. So I want us to understand what I'm doing. I can start clicking this in 1, 2, this and that. But that's taking me like too much of my time. What I'll do, okay. I'll click here and I'll drag. So I just tried to double some things, right? Let's just go. So you can see for the TV, it's assumed that that's the load profile. The hourly consumption in watts. Okay. So are we here? Are we done with this place? It's understandable if you look at here. This is during the night, during the sleeping time, or whatever, the load. So whatever load you define, the graph will show you what it is like here, for you to know what your peak load is. So if you are done here, I'll move. So I'll say, okay. Now, if it is something that I use often, I can come here and I will say save. If I say save, I want to create different load scenarios. I'll click save. I'll come here and I'll say Abuja home. Assuming I have different design, I'll say this Abuja home load. Okay, I'll say save. Then I'll say okay. So those reds have turned to green. Those reds have turned to green, so I've inputted the appropriate values. So you click OK. Yeah, orientation is showing green because you're done with the orientation. So green means perfect. Green means you have fulfilled all the parameters and you can go to the next thing. So I'll click OK. Then it gives me system red. So now I'm going to define the system. And if you look at here, all the parameters of the system is showing red. Then the simulation is blanked out. Every other thing is blanked out because the next item I need to define is the system. Please, if you are lost, you let me know. So I'm going to define the system. So I'll click on system. So under system, I need to define what kind of voltage I'm using. The default voltage is 24 volts. Don't change anything up here. 24 volts. For me, 12 volts is no longer in vogue. In fact, we are moving towards 72 volts. 24, 36, 48, 72 is the end thing. 12 volts is too limiting. even for the batteries. 24 volts, 48 volts is where we are now. Okay, so this is the first window up here. This is the daily usage. This one is automatic. The daily usage is 4,600 kilowatt per day. Because of those added load I added, remember our exercise was 3,400. So there's not much difference between 3,400 and 4,600 because I doubled some of the load. For me, I don't see myself watching television for 8 hours in a day or using fan for 1 hour a day. So I increased some of those parameters. It's normal.
What do you increase the fan to?
2 hours. I increased it to 2 hours. And I increase TV to 12 hours. And I increase my lighting to 12 hours. So I upgraded the load. So it's no longer 3.4. Rather, it's now 4.6. It's still okay. It's still below 5 kilowatts. I don't think anybody in this class
Sorry, sir.
will use more than 5 kilowatts. Sorry?
Hello, sir. I did this, but I'm having a different item.
What did you say, please?
I said my own is also like that, but I'm having different item.
Okay, we'll come to that. The question. Don't worry yourself. You remember what I said? This is just for you to have a grasp of it. Don't be particular about uniformity and perfection. Just relax. Just grasp where the thing is. Like now, we're in this interface. What I just said is that you don't need to touch anything here except the voltage. This one, the tolerance is there. You leave it. Oh, sorry. Requested day of autonomy. 3. Well, it doesn't mean anything. So it has reduced now, right? It's more like it now. So it's 3 days. Right, with 4-volt system. So we are still in order. The capacity is still about 700 amp hour. Daily need is still 4.6 kilowatts hour per day. And the tab that is on is storage. Then if you look at here, it's telling me choose a battery model. So this command prompt in red is telling me what is missing. So it says choose a battery model. So if you look at this place is also blank out because it wants me to choose a battery model. So you can also read this in this small window. It says the precising suggestions are based on the material data and user needs. So if I'm very lazy now, I'll just say precising and it will give me its own design, but I don't want to do that. We'll still come to that anyway. So it said define the precising condition, the PLO, the autonomy, and the battery voltage. You just define it to give you what you want, right? Then the next thing is say define the battery pack. Default checkboxes will approach the precising. So what you have here is the precising, but we need to choose the battery model. Then after the battery model or the storage, we go to PV array design. Then after the PV array design, we now go to the backup. These are the procedures. So precising is this. And the second one is now under this tab, storage tab. And under the storage tab, I come to this window where it says specify the battery set. Are you defining it in terms of the voltage, the capacity, or the manufacturer? It's a choice to so maybe we'll define it. First of all, let's look at in terms of the voltage. And in sorting batteries, are you sorting by technology or by manufacturer? So I will sort by technology, and I will start with lead acid technology. So I'll come here and I'll click lead acid. Then when I click lead acid, it will ask me Is it 12 volts, 50 amp, lead seal gel, frequency 50, blah, 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 and it had been manufactured since 2018. I'll open this flyout, this small flyout here, and I'll go and choose 12 volts, 200 amp hour battery. Any of these two. So it has sized this for me based on its own. It says the number of batteries I need is 6. And those batteries, we have 2 of them will be in series because I'm choosing a 12 volt battery, isn't it? So for me to achieve a 24 volt system, it means 2 of these batteries will be in series. Are you with me? While 3 will be in parallel, and that will give me a total of 6 batteries. Okay. So, any questions so far?
My question is this. You said we should only choose the battery type.
Can somebody, madam, go ahead, come again.
You said under that source batteries by, we have Narada, we have battery type.
You can sort battery by manufacturer. If you open Narada, it will give you all the manufacturers in the world.
That's what I'm saying. I want to ask a question from there.
Okay.
Because by default, what is on my own system by default is that universal. So when I left it at that universal, where you have that Narada, when I left it at that universal, it did not give me 12 volts. It only has 2 volts. And I'll try.
No, you open here. You open here. You open here.
You only have 2 volts.
Oh, okay. Yeah. That means universal does not have. So go ahead. Go ahead.
Narada, that was when I have this thing you are having.
Okay, good. That's a good question. That's a lovely one. That's why I say you need to play around. So go back to Narada or go back to a battery make that has a 12 volt battery. So the universal one is these Indian batteries that have been outphased and comes in small cubicles. Volta should have a good battery. Volta. Oh, they don't have 200 amp. So if I use Volta, I will need 14 batteries. Can somebody see what is happening here?
So that means we have to.
I think I should use Volta. Volta is not bad. Volta comes in 100 amp. So I will need 14 batteries against 6 battery of Narada. Narada is 6 battery because Narada has 200 amp hour. So let me use Volta. Volta is a known product, sort of. But unfortunately, it's an old battery. You know why you can see that Volta has only 2. It's because they're choosing lead acid. As I said, I was in Munich for Intersolar. There's this big solar conference that happens every year in Germany, Munich. I can tell you, as big as Munich Exhibition Center, I hardly see anybody that came to exhibit lead acid battery. Everybody has gone lithium. That's why lithium is a dagger. The system is already telling us to go to PV module, but why not play around and find out what it is? For me, this battery temperature should increase to, let's say, that is very important. Battery affects battery life.
We can't hear you again, no. Hello, I can't hear you.
Who again have experimented? What did you get?
Hello, sir, we can't hear you because your line was
You can hear me now. Who else have experimented? Who else have used a different battery set? 12
I have
volts?
used iron.
No, okay. You might get something completely off what we are getting. Just maintain lead acid for now. When I leave this class, you can start with iron. Okay. So you can see everything now. So the system is telling me to choose the PV module. So look at everything that's giving me. That's giving us something. The capacity of the battery is now 700 amp hour. The storage is now 13.44, but the daily use is still 4.6, right? What have you? What have you? Everything is here, but that's by the way. So we'll now go to the second tab. Here's the second tab, which is what is telling us to choose the PV. So we'll click here.
Excuse me, please, before we go to second tab, I'm sorry to draw you back a bit. Why is that battery in series, why is this thing in red?
Okay, we'll find out later.
Okay.
That is not the kind of red we are afraid of.
Okay.
This is the okay, that one is really dark red. This is the red I'm afraid of. Is this red? You understand? Okay, so this dollar red is instruction. The dark one, the dark what do they call us blood? Is it blood red or red? Is it instruction? So this is the red, pure red, sort of. Is that okay?
Yes, that's fine. Let's go on.
Okay. So we're going to PV array now, which is second tab. So click on PV array. Right? So under PV array, you can choose PV based on product manufacturer or the make. So Longi, Luxor, so many of them. I don't know which one. First Solar, CSI Solar.
You can use AEG. AEG.
AEG, okay, that's a good one. Okay, so now that I use AEG, I will now choose the solar module. Remember, when you calculate the area of your solar panel, you now choose, like we got about 5,400 watts as the power we need, right? If you divide it by, let's say 200, it will give you 27 units. So which kind of solar do you want? So your AEG, the least they have is about 300 peak hour. So let's use AEG 300. Since 2019, they manufactured it. And there's a mono crystalline. So this is it. So you can see that it's giving you the voltage and the open circuit parameters is all there. So what else do I need? I can still use your products as my universal controller, right? The system, as it says, voltage doesn't match the battery pack. So because I'm using a different battery pack, so let me leave it as universal controller. So leave it as universal controller. Because if you use a proprietary controller, the parameters might not fit into the generic. So I want you to be conscious of that. So I'm using the generic controller and I'm using maximum MPPT. So that's where we are. And here, there's no fault, there's no instruction, whatever, as per error or something. So I'll quickly go to backup. Am I using the generator backup? I don't think I need it. If the generator backup, I use it. And it is giving me a small sketch of what I have done so far, which is just like to fulfill all righteousness. Okay, so here, are you here now? I'll click OK. So immediately I click OK, my system turns green, my losses are normal, my losses are within range, then the system tells me that I am ready for simulation. Who is here now? Say, hey, I'm here. Who has gotten to this point? You can go back to system and edit more. You can click back system and it will come back to where it is. So one thing I have done here, which I want to recreate, is that I changed my days of autonomy to 3, and I changed my system voltage to 24. I don't think anybody will be doing any system design. It doesn't make sense. Absolutely doesn't make sense. Okay. Then the next thing I did was to, under my array, I make sure that I use a universal controller. This is just important. Even the system advises you to use a universal controller. Because if you use all this generic, that means I might have to go back and start using AEC branded battery so that it can work with your own controller. But when I say universal controller and I say MPPT, the system automatically gives me the number of strings and tells me how we define that system. Okay. So all I need to do is to click OK again. Any questions so far? I doubt. So how many people are here? Let me go to the chat box. Okay, Moses is there. Who is there? Is your rotation showing green? Is your user need showing green? Is your system design showing green? Is your losses showing green? If you have followed what I've done, yours will also be green, like mine. So I have 3 people who have done the design. 4, 5. 6. Okay, 6. Okay, I'll explain backup. Backup is if you want to use generator backup, you go there and define it. That's what backup is. Is there any backup power? The idea is to give you a better result, right? And maybe it has use. I didn't define the backup, but if you are defining the backup, maybe it will give you more economic parameters on the system costs, which I will show us shortly. Okay. I've seen your message, Mr. Engineer Osondu. You chat me after the class, and I will send you the materials and the video recordings of all the classes. Okay, so let's go back to the class. Who again have gotten to this point? I've seen like 8 persons who are here. I've defined my orientation. It turns green. Perfect. My user need is green. I'm loving it. My system is top notch. Then my losses are green, showing that I'm safe. Then I now have to run the simulation. So click on simulation, run simulation. The system will run a simulation and will give me another page with different results. So let's look at the results. So the project name is my home system. The site is Abuja. What type of system is it? Is standalone system, and I simulated it in a date that I don't even understand what it's saying, but that's by the way. PV module type 300 watts, AEG model is MC, whatever. The battery type I use is Volta battery, 100 amp hour, 24 volts. Total battery capacity is 700. My MPPT current is 9.2. My MPPT voltage is 32.5. Nominal power is 1.2 kilowatts peak. The losses are there. The system for a year, the total system production for a year is 1645. Specific production is about 137. The other one should be losses, I suppose. And so on and so forth. So performance ratio is at 0.7 approximately. Remember our performance ratio. So the first graph is showing me system energy, daily system energy, right? And what have you. The second one is performance ratio, and so on and so forth. So what I'll just do here to have it in a more complete form is to click on report. It will generate a report. So here's the report. So let me make it bolder. So it's giving me simulation. Why is it putting PVsyst trial? Because I'm using a trial version. If I'm using a paid version, then it's not be putting this trial for me. So the first one is the project summary. The second one is the system summary. The average power consumption is 4.6 kilowatt hour per day. And number of module is 4. The technology is lead acid. Number of units is 14 for the battery. The voltage is 24 volt system. The capacity of the battery is 700 amp hour. And the summary, the total energy for the year the solar is giving me is about 1371, which is the specific. Performance ratio is about 70%. Solar fraction 97. Available energy is about 1900 kilowatt per day per year. Unused energy due to inefficient of use is about 278 kilowatt hour per year. So that is where I need to optimize. That is where optimization comes in, just like Jashima said. I need to know what equipment I need to use. Those are supposed to use in daytime when the sun is out. I will isolate them. So this is page 2. So we go to page 3. You click on this here, this next page. So page 3 will give you more parameters, the PV array characteristics, right? The manufacturer is unknown, is a generic manufacturer, but it's going to be 300 watts peak. Number of modules is 4. The string is 4. And just one string in series. The battery is there. The minimum discharging is 20%. So that means VOD is 80. So that's a high efficient lead acid battery from Volta. I know it's expensive. So unlike we said, TOD 50%, it's just for you to play safer, right? Because you don't know the maker of your battery. But you can see that if you're using a Volta battery, it can guarantee you of 80%. But you as an engineer, you know, in order to have a higher safety factor, you can reduce it to 60 or 70. Okay. So that is the parameters of the battery, and then these are the losses. And this is total area you need. It's about 7 meters square is what you need to achieve that. Okay, losses might be complicated. So the next thing, I'll go next, page 4. Page 4 will give me the user need, how my consumption pattern, my load consumption pattern is. So this is what it is, if you remember. And this is what we imputed. This is the battery, the fridge. This is the power for the fan, 2 hours usage. TV is 12 hours, 13 hours per day. The lamp is 12 hours. The light is 12 hours per day too. Go to the next page. So It's giving me the other results, performance ratio, the energy needs, you know, in very concise form. So this is my power consumption all through the year. Available power and all other variables. So diagram is the loss diagram. And how the losses are incurred. Finally, the simulation output. Any question? So you can see page 1 to page whatever. Then after that, I can say save as PDF document or export. So let me save as PDF. Let me save it on my desktop. So I've saved it. PVsyst results reports. So this is it. So this is the PDF of my results. So this is it in PDF. But with the background to embarrass me that I'm using the free version. This is free actually. Somebody say, why is the simulation date not current? Maybe that's part of what they did to penalize me for using a free version, so that I will they embarrass me before my client. Or maybe I need to go and do some settings. I think I need to do some settings. Yeah, I need to do some settings. So I have to go back and do some settings. Okay, so I've printed in PDF. I've not tried this export before, but I don't know what it's going to export to. Maybe to export the data that I use, so I can use it somewhere else. Okay, so here I'll now come here. It says report option. I don't want to pause with all this. You can try all this one. They're not necessary. I'll say close. The next thing you try on your own is that you can come to economic evaluation. It says installation cost amount is null. So it says, is it by global? Is it based on per square meter? And so that I will know. Unfortunately, I'm not going to see Naira here. I would have used Naira, but let me see. Who knows?
Please, how do we get to this page you are?
I click on economics. Economics. The whole
Is it
Nigeria
on the
here. See here, economic evaluation under report. There are other things you can get from these results. There's report, there's table, there is many things, right? But these are things that I'm leaving you to play around with. I have done the basic thing. Unfortunately, there won't be any time to make you do your own while I assess you. But I have no doubt that you're going to grab it. So if I click on economic evaluation, I can come here and I will impute all the values. Since let's deal in dollar or US dollar. So PV, I open it. What is the unit price in dollars? So let's say $70. And support for module, $20. What is the cost of the battery? Let me put $600 per unit. No, that would be too much. It's not to that. Let's say 300. What is the cost of charge controller? Charge controller should be like $24. By one, right? Then installation. So I can go through everything now. Wiring, combiner bus, all these one. What are their costs? I don't think I have time for all those things, but let me quickly. Installation. What will it cost me to install it? The module? Let me say $50. No, $200. Inverter. Okay, transport. To set it up. If there is yearly cost, land rent. I guess you all understand what I'm trying to do. Okay. If there are things that I've done here, operating costs, bank charges, or have you can put all of them here. So yeah, it's already giving me the result. It's telling me it's unprofitable based on because I didn't gauge these things. It's unprofitable because it has calculated the cost per kilowatt and what have you. So I'll go to parameters. Okay. The lifetime, I'll change it to in 5 years. Inflation. If this is Nigeria, I'll say inflation 50%. So here it's giving me some bread. So investment is this. So what will be my own fund? $5,000. Subsidy, 2,000. So I think some of the cost I put there, electricity sale. I say no sale. So I can see how this thing says unprofitable. I think it has to do with that in 5 years. So this 5 span, let me change it to let's say 3 years. Still not profitable. Okay, so it's giving me the payback period, it's giving me all the parameters I need, right? And annual tariff variations. So these are something you will learn on your own, just to play around with it. And giving me report here, though not in red, but in pink. So that is that. So this economic analysis, I think is a new thing, something they've introduced new in 7.4. It's not usually there before, but you can have your time, you can sit back and you can really exploit. Yeah, due to the solar panel we need, they say we need 4 panels. Yes. Any question?
Yes, I have a question, sir.
Okay.
I want to ask if you want to do what's it called for office development, can we still use this same process?
Yes, of course, definitely.
Because I remember that when we are under that user need, there's nothing under the user need that we have the other time. There is no, when we are describing, it's only for consumer that is there.
So under user, there are more options. The other ones are 0. So I can't even say any consumer here. What do you mean by consumer? Can you see it?
You said?
Look at the user needs.
That's what I'm saying.
I think for user needs, for office use, the the consumption will be for maybe daily and daytime consumption majorly. Maybe those
Yeah, if it's daytime, you go to our
7.
information here and set it up and set it here. You understand?
Okay.
This is 0 hour, midnight. This is till morning. This is till 12, then midnight. So you can see why my load is, I put most of them under when there's no sun.
I understand. What I'm trying to say is, for example, for industries that they will use machines and all those stuff. I just want to know if it's still going to be the same process that we have gone through that we'll go through.
It's the same. It's the same. All you need to come here is to put in the load. Sometimes this load itself, I can just come here, I'll put house 1, I'll put their total wattage. House 2, I'll put the total wattage and check what they're consuming. I mean, you can play around with this. If you click, if I need to add a new equipment, I come here now, say I have 2 units of dishwasher, and the average power is 100 watts. So update. What I now need is 5,000 watt hour per day. You understand it?
Okay.
Time check. Engineer Uche. It's 12
Yes.
already.
Yeah.
So
I'm waiting for
close.
questions. Okay. So, gentlemen, any questions so far? So that is all about use of PVsyst for your design.
Hello, sir.